Hello, this is Rahul. In this lectures, I am going to cover the OSPF protocols. OSPF protocols use the link state routing strategy, and link state routing strategy use the Dijkstra algorithm. Before going to learn these protocols, make sure that the topology of network is already known, or we know the number of devices which are connected in the network, or router knows the other routers which are connected in the network. So we'll see the first Dijkstra algorithm concept. Then only within a minute you can understand the link state routing. Sorry. Suppose we have a source and the algorithm called what algorithm returns us? It returns the shortest path from a source to other routers, other devices. Suppose we have a source, and what is the process behind the Dijkstra algorithms? We have a source and we simply explore to all the neighbors which are directly connected with this source, right? Out of these neighbors we select which one is the cheapest one, and because cost on each link is given, we will select the cheapest one. Select the minimum cost on the path from the source, right? Next step, we will consider this as a next source which has the minimum cost, and again we will explore the number of other neighbors and find out the minimum cost path on available explored neighbors. We'll select again next neighbors and then explore. This process will continue until we reach the intended destinations. So we'll see this Dijkstra algorithm with the help of example. Suppose we have a graph. Graph has A, B, C, D, E, F, G. These are the routers, and these routers are connected by a link. You can see here, and each links have on their labels. These are the weight, how much the bandwidth delay, and what the cost to be transferred from A to B, which is to cost from A to D will take 3 cost. Similarly, suppose if we want our aim is what, we have to find out least costly corresponding to A. Why? Because we want to know how much cost will be given, will take when A want to communicate other routers. Suppose A to B, how much cost, A to C, how much cost, A to D, how much cost, A to E. There may be multiple paths. We have to select the optimal one. Suppose we start from source A, right? We explore all the neighbors corresponding to this source. You can see in these pictures we have explored here, and at D is explored and B is explored. On top of B, we write down the cost, which is from source to B. Source to D is cost 3. We have written over there. And next step, we will find out of explored vertices which are not being even used to explore its neighbors. So we out of these B and C which having the minimum cost to reach from source to the device. So 2 and 3, 2 is the minimum one, so that's why we start exploring from 2. We go to explore C and E, sorry. So we will update the weight on C and E. Similarly, up to B we had 2 plus this value, the 5, 7 will be updated here. 2 plus 4, the 6 will be updated here. So we have we explored this vertex, this vertex, but out of these the 3 vertices we have to find out the minimum minimum cost on these paths. So 3, 6 and 7, out of these we will select this one because this has the minimum cost. From D we will explore the vertices. We see We try to update weight on is it's because 3 plus 5 this goes to 8, but already from source to E reaching cost is 6. Then we will not update 5 plus 3 because 6 is less than 8. So we'll explore further other verses. We had this one, we had 2 divided 7 is there, and 6 is there. So out of these these two paths, we will select first the E1 because 6 is less than 7. So from E we explored all the others, the others routers, sorry, others routers, neighbor routers. We'll update the weight 6 plus 2, that is it. uh, Similarly, next step we will see 8 and 7. So we'll start exploring from 7. We'll reach to the this one, and uh, this will update to 7 plus 3 10 over here. And next step we explore from this one. This will update 8 plus 1 9, and compared with already known distance from source to the E, which was 10. Then we take minimum of these two value 9 and 10, we get 9. So that's why we updated here 9, right? So the path we have covered from source to other routers, we will simply draw it, and with the help of this least cost tree, we prepare the forwarding tables for router A. Similarly, we will do same things for router B and C, E, D, E, F, G. For each routers, we do the same. We will run the Dijkstra algorithms and find out the path, least cost tree. Thank you.